You listening when I do the breakup? So mod is about common remainders when dividing. And that's really all you need to know in order to pick up what we did yesterday. And then there was some division stuff. Okay, so that's all online. Sorry. High class. All right. All right. So there's rules. There's a sum rule. There's a product rule that works very similar to the sum rule. Don't get hung up. Someone, fifth hour, mentioned when they were looking at the homework. This says use Rule 4, but you have it Rule 3 in the notes. It's the sum. You start off in your homework. Use the sum rule that I show in this first example. So don't get hung up on use rule or look at the book and see what rule. But it's not really that. Just do what we're doing here. So the first thing, actually, this is not one that I would have to teach because this is something. Well, actually, I will tell you where my brain had a tough time wrapping around this. I'm an Algebra 2 pre-calc teacher, and this really, in my mind, should have parentheses on it. You're modding the whole sum. This, to me, looks like 54 plus, and then whatever 67 mod 3 is. It blew my mind at first. But it's actually you're modding the whole sum. So I don't know if I'm being weird looking at it that way incorrectly, but add these two would be one way to do this mod. And then, so 54 plus 67 is 121. And then just use your calculator to find out what this is. Oh, and I didn't say something. I'm sorry, in this modular arithmetic, you want the smallest, you want to change this to the smallest possible number in this position. So you want to change 121. What are my three options? I mean, you have a 1 in 3 chance of getting this right. Look at the mod. Your mod 3, you're dividing by 3. So what are your possible remainders? 2, 1, or 0. It's one of those three. So when you're doing this modular arithmetic, I like to almost call this, you want to reduce it at the end to the smallest possible number that has the same remainder as, in this case, 121. Remember what we did before? What's 1 plus 2? 3 plus 1. Oh, so is this divisible by 3? But what is 1, 2, 0? You got to go back. You guys keep going forward in here. Remember when you're dividing and you think 4 divided by 13, reverse that, 13 divided by 4. How many times 4 go into 13? It doesn't, but it goes into 12. Remember, you go back. So 120 would be the one. So anyone know the answer? What's the answer? What's the answer? No. What's the answer for 0, 1, or 2? 1 mod 3. Because this is 1 off from being a perfect, being a 0 for a remainder. So again, you better get this idea. Mods about remainders. What's the remainder? Or, if this number, you don't have mod 3, you have mod 4, mod 7 with no fancy rule, physically divide 121 by 3. Analyze the decimal. You get 40.3 repeating. And then understand what I told you yesterday. This is the same as when you went in grade school and first took the remainder and put it over the divisor. 0.33 repeating is 1/3. So the remainder is 1 when you take 3 into 121. So therefore, I can change 121 to 1 mod 3. These are equivalent because they are both numbers that have a remainder of 1 when you divide by 3. And how you get that real quick is take 0.33 and multiply it by the modulus. 0.33 times 3. So over-explaining that, hopefully that puts it together. Or, this could be a non-calculator question. What you can do with a sum mod 3 is mod each part of the sum and then turn that around and get those A values and add those A values back. So reduce it. And I probably didn't say that in a great way. I know what I meant to say. Probably didn't come out so great. So here we go. What's 54 mod 3? What could it be reduced down to? I don't know if I'm using the word reduced correctly, though. 0. What's 5 plus 4? 9. That's probably how they got 0 so quick. So 3 goes into 54 evenly with what as a remainder? 0. That's why I could write this as 0 mod 3. All right, gets a little bit more challenging on this one. How many times does 3 go into 67? Well, it goes into 66 with a remainder of what? 1. And then what you can do is turn around and reverse the sum rule. Now I can add these two numbers together. What's 0 plus 1? 1 mod 3. That's a liberal use of the sum rule with mods, kind of like skipping some steps, I guess, of what's written up there. Do you notice that the answers are the same? Okay. All right. So what I told first hour and fifth hour, I could do the second one, no calc. Yes, you have to be numerate. Do you know what numerate means? Good with number. Just like literate means you're good with reading or English or whatever. So yes, I expect times tables and you to know those things, blah, 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 blah. Then a liberal use of, I don't know if it's number 4 in your book, product rule. Okay, this one's a calculator, so this could have been on yesterday's homework. Really, it could have. And again, I don't think I said this. In your modular arithmetic, this is the third time I've taught it, so I know I'm hitting it now in case I might be repeating myself. In this modular arithmetic, what you want to do is do the arithmetic and then get the smallest possible number in this position. That's the rule for the day. I don't know if that's implied in the notes or the questions. Okay, so in this one, no, there is no 7 division rule. This one you physically do have to divide 496 divided by the modulus 7 to analyze this decimal. Now remember what I said. Take 0.8571 and multiply it by 7. You get approximately 6, not 6 on the dot because that's a rounded decimal. And then what this means is this is the same as 70 and 6/7, and the remainder resides in that numerator. So that is the remainder when you take 7 into 796. So what can I put right here as the smallest possible number? The remainder. So again, the reason this is 7 goes into 6. How many times does 7 go into 6, by the way? 0. What's the remainder then? 6. This number has a remainder of 6 when divided by 7. This one has a remainder of 6 when divided by 7. These are equal moduli. So therefore, we're writing the smallest possible positive 1. Or you could take the product and take each part of the product because I'm a jerk and I say, you know what, this is a no calculator quiz right now. Huh? How do I do 16 times 31 on the no cal? Well, you do the old school multiply. And then how do I divide 7? Well, I take this division bar. No, you're never going to have enough time. And actually, first hour, I gave him a longer time on the bell work because I was doing stuff. And I had a lot of people doing that. They were doing long division. I was like, oh, boy. All right, so that's why you got to look for these tricks and know these rules. So what I could do is mod each part of the product. All right, so what's 16 mod 7? Or what's the remainder when 7 goes into 16? 2. So what can I rewrite this as? 2 mod 7 times, what's the remainder when 7 goes into 31? 3 mod 7. And then I'm going to add one more. This is a congruent symbol, by the way, but this book uses 3 straight lines. Congruent usually has a squiggly on the top. I don't know. Hey, just whatever. Then what you can do is 2 times 3 mod 7. That's the liberal use of the product rule. And then, hey, lo and behold, these numbers are the same because it's 2 different ways of doing the same thing. One is a little bit easier if you know the rule. Easier mathematically, I would say. Oh, I didn't tape any of that. I'm not repeating it. You don't need me for this. This is like a yesterday's homework question. We went through all of it right here. But jerk Mr. Samulus says no calculator today. So now you got to come up with something different. I don't expect you to take 2 to the 10th without a calculator. Might be possible. Takes too much of a long time. What I'm trying to get you to do is use these rules that I'm liberally using, I guess. So what you can do is an exponent rule. Exponent rule you should know. You should know a couple of them. The sum rule, when you take x to the third times x to the third, you add the exponents, right? So I'm going to break 2 to the 10th. I guess you have options. You could say 2 to the 6th and 2 to the 4th. You're making yourself difficult, though. Why not 2 to the 5th twice, so you only have to do one evaluation? What's 2 times 2? 4. No one said anything. 2 times 4. 2 times 8. 2 times 16 is... So this is 32 times 32 mod 7. Okay. Now, I'm not going to write this. I think first hour I did. What you can do now is mod 7 each part of these products. So how many times does 7 go into 32? Well, okay, I shouldn't say that. What's the closest multiple of 7 to 32? 28. Again, you need to know your times tables. Those that are searching around, I don't know. I think there's one in your planner. Isn't there times tables in your planner? Better memorize it. You're never going to get to use it. All right, so what's the remainder when 7 goes into 32? 4. What's the remainder? This is why I did 2 to the 5th twice. 4. And then, why is there 2 more lines? Well, what's 4 times 4? This is not the smallest possible mod 7. Now you actually have to go a little further. What is the answer? 2. The remainder when 7 goes into 16, 7 goes into 14 with a remainder of 2. Isn't this fun? Some people look like just want to kill me or something. I don't know. Hey, I'm just the informant. This is weird. Actually, don't look at this. This is out of order for right now. All right, Mr. Samuelis is mean. He gives me this question. Why does he make me do these things? Well, you should have some mathematical stability here about how to deal with an exponent. And then I'm going to liberally, got to listen because I'm not going to maybe per se write it, but this is what's true. What you want to get this down to is down to the best possible number for mods, and that's 1, a remainder of 1. Okay? So I want to find a 1 mod 7 out of 2 to some power. So I have 2 to this ugly power. Right off to the side you go, all right, what's 2 to the first? 2. What's 2 mod 7? It's 2 mod 7. That's a number less than 7. What's 2 squared? 4. Well, that's 4 mod 7. That's it. That's what it is. 4 is smaller than 7. I can't do anything more with that. Now here comes the magic. What's 2 to the third? 8. What is 8 equal to? Well, how many times does 7 go into 8? Once. Okay, then what's the remainder? 1. So 8 equals 1 mod 7. So now what I want to do is I want to work with exponents to get an 8 out of this secretly. So this is what you do. All right, first of all, 2 to the 302nd is 2 to the 300 times 2 to the second. I am going to put that up there right now. You better know your exponents, though. Why? What do I do with those exponents? What do I do with those exponents? Add them. So I know that's the breakdown. Then the next thing is, why did I pick 300? Because 3 times what is 300? 3 times 100. The next rule for exponents is, when you have a power raised to a power, what do you do with those exponents? Off to the left here? Multiply. All right? So now what I've done is written this not as 2 to the 302nd, 2 to the 300th times 2 to the second, but then I wrote 2 to the 300th as 2 to the third raised to the 100th. All right? So this is just algebra 2, man, or woman, or whatever you are. All right? That's all it is. So, now what do? We liberally use the product rule and the power rule, where the power rule said if A equals B mod whatever, then A to the K equals B to the K mod whatever. What's 2 to the third? 8. Now just follow with me because this is how you can do it. And this is why you got this 8 here. So what is 8 mod 7 equal to? Because we could switch these. What's 8 mod 7 equal to? 1. All right, and that's what I did, and I kind of circumvented the system, but that's how it works, believe me. So 8 mod 7 equals 1. You actually could interchange these two in a way as well, but that's what's happening to the 100th power times 2 to the second mod 7. So I know it's kind of a liberal use of the mod, but that's how it works. Now, what's 1 to the 100th? 100. No. What's 1 to the 100th? What's 1 times 2 squared? 4. This is 4 mod 7. So now what you can take to the bank is, when I take 2 to the 302nd power and divide it by 7, what's the remainder? 4. It's either going to be 0, 1, 2, 3, 4, or 5, or 6, no matter what. But in this case, it's going to be 4. Hey! Now this one I kind of shove in your face. I forgot all the classes to erase it and actually do it with you. It's the same idea with a little bit more complication. You're dealing with 3 to a power. And by the way, I don't know if I said this in the last one. If you take 3 to the 203rd power, you get some E number. And then you divide that by 20. I'm not even sure what the calculator spits out what it looks like. It may not even be workable with a calculator to, get the remainder being 7 in this case when we actually do this. So even with a calculator, this may not be one you could do with a calculator. I don't know. I haven't even looked at it. Sure, it's fine. All right, this division thing is to try to find, some powers that work out with this, but you don't do any of this yet. You don't do any of this. This is last. What you do is you go over here and say, all right, I'm dealing with 3. So it's 3 to the first, 3. What's 3 mod 20? Can't do anything with it. 3 squared, 9. 9 mod 20 is 9 mod 20. I'm looking for what mod 20? 1 mod 20. 3 to the third is 27. 27 equals 7 mod 20. Why? 20 goes into 27 once with a remainder of what? 7. That's why it's 7 mod 20. Now, 3 to the fourth. Yes, I expect you to be able to do that without a calculator. 3 times 3 is what? 3 times 3 is what? Now, I did that on purpose. I have 2 9s. What's 9 times 9? I wasn't doing that to make you say it louder. 3 times 3 is 9 over here. No, 3 times 3 is 9 over here. 9 times 9 is 81. You should know 3 to the fourth is 81. 20 goes into 81 4 times with 1 as a remainder. I found my 1 mod. Now, what I do is go back to this and try to use my glory and power of exponent rules to get a 3 to the fourth in the mix. This is Algebra 2. And CAT, for those that were K. Got 2 years in a row of these exponent rules. So again, that 203, that 3 is messing up things. Because I know I need 3 to the fourth. So 200, 4 goes into 200. So 3 to the fourth raised to the 50th equals 3 to the 200th. So if you want me to write that up here, what I first did was 3 to the 200th times 3 to the third is what this is equal to. And then I broke down 3 to the 200th to the 3 to the fourth that I needed. I needed the 3 to the fourth because that's a 1 mod number. And then, I know it's weird, what's 3 to the fourth mod 20? Well, that's 81 mod 20, which is equal to 1 mod 20. That's why the next 1 to the 50th power is written there. So this is a little trick, a little thing in order to do this. It's very doable. I know it's weird. Don't care. We actually have to figure this out so we can use it in some other things we're going to do starting Monday. And then 3 to the third. Why is this 7? What's 3 to the third again? What's 3 to the third? 27 times 1 is 27. 20 goes into 27 once with a remainder of 7. That's why it's 7 mod 20. Okay? So this is what you're ultimately doing, trying to get the smallest possible number that's the same mod 20 as this number, I guess. All right? Has the same remainder, if you will, but then the one that's between 0 and the modulus. Final answer. Okay, I am done.